Hi there. So this is the last block on incremental data load, and the logic or the feature that we are leveraging here to derive the incremental data or harvest that is CDC. CDC was introduced as SQL Server 2008 and is one of the best features to have been a part of this product. As such, CDC offers an asynchronous data harvesting mechanism with the help of transactional logs or the transactional log sequence numbers. So whenever there is a transaction happening for a particular table or on a particular database, usually what happens is the transaction doesn't get directly committed to your MDF files. It actually goes into the transactional log, and from where it is finally written when the SQL Server issues a checkpoint. Now what happens in short is each of the transactions is being monitored or by SQL Server with the help of a unique identifier, which is LSN, that is log sequence number. So any DML that you fire on SQL Server and there is a transaction happening, SQL Server from backend actually monitors that with the help of a LSN. So CDC uses the same feature along with the replication. It could be said an in-house inbuilt mechanism for replication. So basically it creates its own capture tables, and with the help of which it uses the LSN numbers and then logs the changed data. Now what it does is it logs the changed data with the help of the transactions that happen and the sequence in which they happen. Now this is an asynchronous mechanism, which means the database or any transaction doesn't have to stop for any acknowledgement or to get it committed or to be written or logged by the CDC, and it can go on while the CDC works in the background and helps us to leverage that incrementally. Now let's try to use that feature and see how quickly we can implement incremental data load from a source. So what I have done here is I have created a CDC POC database. Now this database has been created on one of the instances as it has been for my other blogs, and this forms to be the source. Now in the target, what I have here is I have another instance, and there I have a target DB, and I have created a customer underscore target. So we can fictitiously assume this table to be our production table on which we want to sync the data. Now this table has to have a primary key for us to, the source table on which we are actually implementing CDC needs to have or conform with a constraint that it has to have a primary key. Now this project or this tutorial is not on CDC, so if you want to understand CDC, I have a blog on, I have an article on code project on which you can refer, actually the link of which is at the bottom of this video on YouTube, so you could refer that. But this video uses the CDC feature as such and tries to build a mechanism of transactional data, incremental transactional data load. Now usually what CDC, most of the people do is actually they depend upon a time. They would fire the CDC or incrementally load data in each hour. I disagree on that, and would rather go about it with the remaining transactions, which means is I would want the capability to fire my CDC SSIS package to incrementally load data at will, and if there is any remaining transaction which needs to be synced up, it should be able to do it, or it should say no, I do not have anything. The process should harvest data from source and put together whatever data needs to be synced up with the target, and if there is nothing, it should not bother the source at all and abort the process. It should not be a time dependent thing. Rather it should be at will, and it could be scheduled at any particular time that we wish like. So going with this approach in mind, let's try to see what I have in place for you guys here. So I have this table, that's customer target, which has been built on my target DB. We'll try to sync this table. Currently this table is empty, and I have created a database on my one of the instances, which is CDC POC, and let's try to enable CDC on this database first. So what I do here is you need to first enable CDC on the database level and then from where you can move on to the table level. So first let's try to enable the CDC on database level. rightly so, we are done. Now to check that if that has been configured correctly, you can fire this query, which would give you the series, the database name, as well as the flag that has been enabled or not. So we are good with our configurations. Next let's go and enable the CDC on our table level, that is the customer. Let's create a new role and go for support net changes. What this would do is this would create two jobs on our server, on the instance of our server, and these jobs will be a part of your data harvesting and cleanup. So they would be actually populating the inbuilt capture tables that CDC leverages, and at the end of this you would see two tables, two jobs being created. So one of them is the capture job and the other one is the cleanup. Let's see if we have those jobs in our agents. Now I should be having two jobs, and rightly so. The cleanup job, to give you a brief, it runs in every 2 days by default, once in 2 days, that is 48 hours, and the capture job runs every 5 minutes to capture the LSNs on which the change has occurred. Now let's move on. We will try to insert few records, and then we'll try to see how good are we with our incremental load. So let's try to fire couple of queries first and see how our data is being loaded. So I have a stored proc which I'll explain later. First let's try to see the demo of our CDC mechanism. Right, so I have done some couple of inserts and updates. Now my final source looks like I have two tables. I have inserted two, deleted one, and then I have inserted one again and then updated. So I have three inserts, one delete, one update, and the final data looks in my customer table something like this. Now what I do here is, this is the SSIS package that I have built for harvesting and then populating my target. Currently my target is empty. I do not have anything in my target tables, so I do not have anything. So let's try to run this SSIS and see if we are right. Now let's try to take a look at our target table. We have two records and they have been properly synced up. Now let's try to make some more deletes and inserts. I try to delete a record and then insert another. So this would be a third. I'm deleting a record with customer ID 3 and then reinserting it with a different value. Right, so let me run this SSIS all over again. What does my source look like? My source looks like 2 and 3. Perfect. Now what my target looks like, 2 and 3. Perfect. Now let's try to do one more time and see. What I'll do is I'll insert an update. I'll insert the same record and then I'll insert a record and then update this same record. So in a transaction. So now what my customer table, this is looks like, I have Millie, where I have inserted and then updated her age. Okay, so let me rerun this SSIS package and try to sync my source data with the target. So now I have inserted a record and then updated this age, and everything looks fine. So now let's go into the hood and see how this is actually happening. So before we get started, the first step is to run the stored procedure on the source. So basically the source is the CDC POC database that I'm running everything on, and to give you a brief, the target is again the different server on the second instance. That's all, and the first step is to run the get delta stored procedure. What this stored procedure does is it actually uses two of my tables. So this stored procedure is actually harvesting the data. This does the job of harvesting the data. So before that, I'll introduce you to two tables. The two tables that I have built for my custom data harvesting is, I call it customer delta audits and then customer delta data. So what this table schema is, it has an audit ID which is of identity int type, and it's a primary key cluster, and then I want the start and the end LSN, and then an audit time when this audit happened for the data, and a flag for each data synced. That means if the data, if this flag is of a value 0, our SSIS package will try to pick that up and then process it. Next, what I have here is a customer delta data. This table actually has it's another primary key, as we could call it a sequence ID, and then the audit ID is being referenced for the other customer delta audits tables audit ID. Then we have the operation, if it was insert, update, delete, and then the operation description, and then the data for the tables. That's all we have. Now to give you quickly what I have currently stationed, and we can also select audits. So this is what is our audit and data looks like. These were these were the things that actually happened. So we actually ran our package 3 times, and these were the operations that took place on all the 3 things. So basically, if you see, the audit ID is the reference to the audit ID of this particular. So the bunch of these things actually are referencing to the ID, to the audit ID for this particular audits table. And then we have 2s and then 3s. So basically this table is referencing, and then it's also populating the update or the operation that actually happened. Now how are we populating this table? For this we have to go back to the stored procedure. So let's look at the stored procedure, and in the stored procedure we are leveraging 2 tables. So by default CDC actually builds a capture table. The capture table for CDC is of your schema, and it appends a CT to the table, that is the change tracking. It tracks this table. So if you look at this, is by default created by SQL Server when we enable CDC. So this is the table for your CDC that is by default is being created. So we are leveraging this. This gives the start LSN, and then we have LSN time mapping. So this LSN time mapping actually logs the LSN for a particular transaction. So if you enable your CDC for 10 different tables, all of them with a time dependent thing will be logged onto this table. So whenever there is a transaction that has happened, SQL Server will log the transaction onto this table with the transaction beginning and end time, and the IDs will be, or the LSN IDs will be maintained in this table. So we are using these 2 tables actually to build the stored procedure and to pull out our changed data. So to start with, the stored procedure first checks if there is a customer delta audit is equal to 0, if there is no records in our delta audits table. If so, it primarily inserts the start and the end LSN. Basically what it does is it joins our CDC customer change tracking table with the LSN time mapping, and then it pulls out this data. So it pulls out the start LSNs, and then it populates this value onto our customer delta audits table. That's all that this actually does. And if there is nothing, if there is no records, only then we pull out everything from this table. Otherwise what we do here is we add a clause. We add the maximum end LSN for customer delta audits should be actually less than, to say so, I mean the start LSN for your LSN time mapping table or the transaction should be actually greater than that of the delta audits table. Say we have a transaction that happened 2 minutes back, and after that, so anything till that point we have that logged into our customer delta audits table. So we need anything which has happened after that. So this constraint has been added, and from here we actually fetch out anything which has happened after that, and then from there we insert these values, we insert the LSN values into our customer delta audits table. So our customer delta audit hosts the start and audit time LSNs, and then we use the scope identity value, based on which we actually again go back to our customer CT table, which is a default created table, and then we fetch anything which had occurred between these operations. And the reason is, for operation not equal to 3 is operation 2 indicates, and 1, 2 and 4 indicates the insert, updates, delete. Now what does 3 indicate? 3 indicates any value which was prior to an update. So if there is a column which was updated to a value of 65 and its a base value was 56, so operation 3 would represent 56. We are not interested in an intermediate or a prior to update value. We are interested in the final value. So that is why we are filtering out the operation 3 and populating everything that is there between the time frames. So and also to explain you, so I have added a column operation description which says 1 indicates a delete, 2 insert, and if there is it's a 4, the only option remaining is a 4, it's an update, it's the final update. So that's what we are doing here. Now if you take a look at these tables, I think it would make much more sense to you. So what you see here is there is a description of the operations that actually occurred, and then there is also an operation value that I have posted here, and then we have the data, and I have added a sequence number. Now if we go back to the SSIS package, this section or the harvesting delta section is quite clear now. Now we move on. Now we actually get the audit IDs. So what this does is actually it gets the audit ID for anything which has not been synced yet. So if you what we do here is we run this query and we try to fetch out. Currently we do not have anything where the data is not yet synced up. So if we have everything is currently synced up, we get the audit IDs here. So everything looks synced up. Now that's the first step to get the audit ID. Once we get all the audit IDs, we loop through each of them with our base table, that is the audit or that is the delta data table. So again, the next for each loop, what this does is we collect the value for I mean here if you see the audit IDs, all the audit IDs are currently put together into a variable get audit IDs, and we have everything. We have the full result sets. So we have the entire audit IDs, and now we loop across them in the audit ID variable and pass it on to the ware audit IDs. Now the next thing is we would collect the sequence. Once we have the audit IDs, now say we want to sync up our data for audit ID 1. So this was the sequence for the audit IDs. So if I say star, let me show you everything. We could say customer delta data. Let's try to see. That's all. So for audit ID 1, this was the data, this was the transaction that actually happened. There was an insert, then a delete, insert, update. Now I want to loop across the sequence of the events that actually occurred and then sync up my data. The reason of doing so or looping so in sequence is because if there is an there is a delete and then an insert, or if there is an insert and then an update, uh, if we do not find the record at all, we would not be able to do it. So we want to do in the same sequence, or sync up the database, target database in the same sequence. So now we have the sequence IDs. Again, we get the full result sets. We map the sequence IDs for a particular audit ID to a particular sequence ID all variable, and then we use a final for each loop where we pass it on one by one and then sync up the data. So here, if you see in the source, we are passing on the sequence ID and the audit ID as parameters, and based upon which we are conditionally splitting the data for insert, update and delete. This is very simple, and then we are simply inserting the data if there was an insert, and then we are deleting it from the target if there was a delete. This is a simple parameter mapping, and then we are deleting it for that particular customer ID, or updating it for that particular, again, customer ID, since our customer ID forms the primary key. So this is a very simple package, to say the least. And finally, we do nothing but we update the particular data synced flag. That's all. For that particular, we get the input for that particular audit ID. Once the complete sequence is done for that particular audit ID, we flag that to is data synced to 1. That's all that we do. So this is how we are actually syncing up. Now there has been no and there is a scenario, there is no transaction that has happened, everything is completely synced up. This is our target and this is our source and target, both of them are good. Now there is no change. Now let's try to see what would happen in this scenario. There shouldn't be anything that you know. So our package is run, there is nothing to be synced up. It doesn't go beyond the actually audit IDs because it doesn't find any audit IDs. So it's still in sync. It's still in sync, and there is nothing that has actually occurred. But if you look at the LSN time, there would have been, it logs every 5 minutes. So basically you would still see some of the transactions. It just flags that there is nothing that has actually occurred, but it keeps on. So the join, which goes to say the least, that the join that we are doing with our capture table, that is the customer CT, with our time mapping table, makes complete sense. So the heart of it, this stored procedure forms our harvesting mechanism, and it completely gives you or pulls out the data which needs to be populated and which needs to be harvested. Now again, this is a demonstration on harvesting incremental data. Yet to say, this is an asynchronous process. This is a way beyond. I mean, it would not cause your actual database any cause of concern because it's an asynchronous process, first of all. Secondly, it's change tracking. We had seen incremental load as change tracking mechanism. It is quite similar. We are not actually loading the entire data, we are only loading the change data. So if there is, again, we have 1 million records and we have 10% of which where the data was changed, you are actually loading or harvesting those 10%. So the load would be immensely reduced. But there are few constraints in change data captures. That is, you have to have a greater piece of skill in terms of supporting them as a SQL DBA, and also the primary key constraints and sync up also needs to be taken care of. The cleanup automatically is done every 2 days, so it's a good way to run your package, SSIS package, every 3 hours or 6 hours. That would keep you safe and keep everything in sync. But supporting CDC requires greater piece of skill as a DBA. Thanks friends, I hope that completes our incremental data load for all the options that we have seen. We have seen incremental data loads via SSIS package. We had seen 3 of the approaches there. Then we had seen change tracking as an approach, and then CDC. Industry wide, we see these options being used, and I wanted to expose this out to my audience. I hope it's really helpful to you guys. See ya.